obstructed due to rheumatic valvular heart disease. Hi all, this is Kavipriyabalu, lecturer, Department of Cardiac Technology. And in this video, we would like to assess echo assessment of mitral valve stenosis from 2D. And here, Sneha will explain how it will be on valve appearance in 2D and which valve get obstructed and doming appearance at all. Yes.
So here, as you know, what is mitral valve? Mitral valve is a valve in between left atrium and left ventricle, which causes the blood flow from left atrium to left ventricle. So, in mitral stenosis condition, the blood flow from left atrium to left ventricle is obstructed. Here, it is a mitral valve. The blood flow gets obstructed from LA to LV.
So forward flow get obstructed. Okay, that is called as stenosis and narrowing of valve.
So the common causes are rheumatic heart diseases, the congenital mitral stenosis, the calcification in the mitral valve, etc. So here, next we are going to see about the rheumatic mitral valvular stenosis. So then we are going to get forward into assessment of mitral stenosis.
There are a lot of ways for assessing mitral stenosis in echo. The first one is 2D and M mode. Here we are able to see the mitral valve anatomy and all the subvalvular structures of mitral valve. We can see the fused commissures and how the mitral valve is taken.
Here showing.
An M mode demonstrates the inner slope due to impaired diastolic filling. The second one is color wave Doppler. It shows the velocity and direction of flow, which is very useful in mitral stenosis. Next is 2D planimetry. Here we can directly trace the mitral valve orifice area, which gives a more accurate anatomy of mitral valve. Next is continuity equation. After that, we have associated echo features. Here we can see a left atrial enlargement and echo contrast, which is thrombus. Overall, we have 5 assessments for echo in mitral stenosis. Now, continuity equation will be explained further.
Continuity equation in echocardiographic method to assess the severity of mitral stenosis based on the principle of conservation of mass. It assumes the volume of blood flowing through the left ventricle outflow tract is equal to the volume passing through the mitral valve during stenosis, which is SV LVOT is equal to SV MV. Stroke volume of LVOT is equal to stroke volume of mitral valve. The mitral valve area is calculated by dividing the flow through the LVOT by the diastolic ventricular flow. Using this principle, the mitral valve area is calculated by dividing the flow through the LVOT by diastolic transmitral flow velocity time integral. Since flow is the product of cross-sectional area and velocity time integral, mitral valve area can be derived indirectly. This method is particularly useful when that planimetry is not feasible, such as in cases of poor acoustic windows or heavy calcification, and when pressure half time become unreliable. For example, in atrial fibrillation, associated aortic regurgitation or altered left ventricular compliance. The continuity equation provides a flow-based and hemodynamically independent estimate of mitral valve area and correlates well with massive measurement. However, its accuracy depends on the precise Doppler alignment and assumes the absence of significant mitral regurgitation or intercardiac shunts. In summary, the continuity equation is a valuable agent for quantifying mitral stenosis, specifically when conventional methods are limited.
So there are totally 6 steps involving in continuity equation to find the area of mitral valve area. So basically the first step is CSA of LVOT is equal to 0.785 into LVOT diameter the whole square. So we can find the CSA LVOT from using the formula 0.785 into LVOT diameter the whole square. LVOT diameter can be found in parasternal long axis. So this formula is used to find the cross-sectional area of LVOT. So the second step is to find the VTI, which means velocity time integral. We can find this velocity time integral in apical 5 chamber by using pulse rate Doppler. So the third step is to find the SV of LVOT is equal to CSA of LVOT